So for today, we are going to learn how to change decimals to fractions. So as you can see on the left, we have terminating decimals, and on the right, we have repeating decimals. So um, to change a terminating decimal to a fraction, you simply need to read the decimal correctly. So this 5 is in the hundredths place, so I read that as 75 hundredths. So I'm going to write this as 75 over 100, and then I notice that both of these can be divided by 25, and I get that this is 3/4. Okay. So here I will read this as 3 and 24. Again, this is tenths, hundredths, thousandths. So I know this can be simplified at least by 2. Whenever I simplify it by 2, I get 12/500. And then I know that can also be simplified by 2, so I get 6 over 250. And I believe that is in simplest form now. We can kind of think about our divisibility rules with that. Here, I read this as 46 hundredths. So I put 46 over 100. And again, I know I can simplify both of those by 2, so I get 23 over 50. And that one is in simplest form. So there are multiple ways to do this. I just particularly stick to this mathematical approach. It's just my comfort zone. You can find other videos on YouTube that do these different ways. So here you will see that this is 0.78 repeating, meaning that this is 0.787878, yeah, and it goes on forever. So the way that I like to look at this is I need to have the exact same thing behind the decimal so that I know it's all going to cancel. I just like to do that because I don't like ending up with complex fractions at the end to where I have to change those once they're in fractional form. So what I'm meaning there is currently I have x. 10x means I'm multiplying this decimal by 10, which moves that decimal one time. So now I have a 7 in front of the decimal, and it goes 8, 7, 8, 7, 8, 7. Well, that's not the same thing behind the decimal yet. That's not the 7878. So if I have 100x, that means I have 78. It moves the decimal twice. And now I have 78, 78, 78. And that's going to continue going on and on forever. So what I'm going to use for this one is I'm going to use 100x, which is equal to 78.78 repeating, and x, because that was equal to 0.78 repeating. The reason I know to choose these is I can just go ahead and cross that part out since they are also the same. So 100 minus 1 gives me 99x equals 78. To get that as a fraction, I'm just going to divide both sides by 99, so I get 78 over 99. So at first glance that might look like it's in simplest form, but if we do 8 plus 7, we get 15. 15 can be divided by 3, so that means we know that 78 can be divided by 3, and we know that 99 can be divided by 3. So we're going to do 78 divided by 3, that's 2 times, and that's 6. So I end up with 26 over 33. 26 is even, 33 is odd. That's a good indication that this is probably in simplest form. This adds up to be 5, so that eliminates it being divisible by 9 or 3. If it's not divisible by 3, then it's also not divisible by 6, so we can be pretty sure that that one is indeed in simplest form. Just to free up some space, I'm going to erase those steps for this one. I personally have 0.3 repeating memorized. This is one of those that I just like to use the shortcut for. The shortcut says however many places are repeating, that's how many 9s you get as your denominator. So this is a 9, and then you just put the 3 as the numerator, and you get 1/3 when you simplify it. Well, let's do this one the long way. So x equals 0.3 repeating. 10x equals 3.3 repeating. I have the same thing behind the decimal, so I can go ahead and subtract these two from one another. This part cancels. This gives me 9x. This gives me 3. X equals 3/9. And then I can simplify it. So, for the last one, this 2 always makes life harder for me, in my opinion, so I'm just going to ignore it. I'm going to know that my answer is going to be a mixed number that has a 2 as that whole number part. So I'm just going to try to come over here and deal with 0.36, where the bar notation is just over that 6. So that means that there's not 3 6 repeating, it just means that the 6's go on forever over here. So this is what x equals. 10x equals 3.6 repeating. Now you could stop here and you could do all your subtraction like I've been doing in the other steps. I just personally do not like ending up with a decimal as my numerator. So I'm going to continue to 100x, which is equal to 36.6 repeating. And these are the two that I'm going to use in my subtraction because they have both 0.6 repeating. So basically I'm doing 36 minus 3 because we know those cancel, and getting 33. I'm doing 100 minus 10 and getting 90x. So 33 over 90 equals x. And again, it should be obvious that both of those can be divided by 3, and you get 11 over 30. Just be aware that I do need to put that 2 back in front of that 11 over 30. When we get back, I'm just going to remind you guys how to change fractions to decimals, and I would have done that with each of these just to check my answer. I would go back into a calculator and check to see if 26 divided by 33 is indeed that repeating decimal. So here are the 4 examples of turning fractions to decimals that I'm going to complete. Starting with this guy, we have numerator divided by denominator. So that means 7 divided by 8. We really can't get anywhere evaluating it this way. So I'm going to put 7 inside the division bracket, 8 on the outside. I personally just always go ahead and add my decimal in 2 zeros. Just out of habit, I may not need that second 0, but I could. So 8 goes into 70 how many times? So we know that 8 times 9 is 72, so that's too many. So we know that 8 times 8 is probably where we're going to start. 8 times 4 is 32. 32 doubled is 64. So that is going to be 64. That's a remainder of 6. I bring down the 0. So clearly this is 60, so it's going to be less than 8 times. So let's say 7 times. So that is 56. I need to add another 0 and bring it down. And how many times does 8 go into 40? We know that is 5 times. and that's 40. We get that remainder of 0, so we can say that 7/8 is the same as 875 thousandths. So again, if we started this whole process over again, we would write that as 875 over 1,000, and it would simplify to be 7/8. So this one, again, I'm going to ignore this whole number 2 and just focus on the 5/6 part. I'm going to know at the end that whatever decimal I get has to have a 2 put back in front of it because I had that whole number 2 there. So again, a numerator divided by denominator, just again, out of habit, I'm going to add my 2 zeros. 6 goes into 50 8 times, which is 48. 6 goes into 20, how many times? 3 times, which is 18. And we should see at this point that we're going to continue to have a remainder of 2. So 2.83 with a bar notation just over the 3 because that's the only part that's repeating. And again, we can go through the process of changing that using the algorithm that I showed you guys earlier in this video. But this is what it equals. So here you really have 2 options. You can just evaluate it the way it is. Knowing that 19 is bigger than 7, we should know that this is going to be a decimal that's larger than 1. So it's going to have a number in front of the decimal. So we're just going to go ahead and put 19 in the division bracket, 7 on the outside. I'm going to add a decimal, and again, I just like to go ahead and add my 2 zeros. 7 goes into 19 2 times, which is 14. I know that I'm good to go here because the remainder of 5 is less than that divisor of 7. Okay, 7 goes into 57 times, which is 49. 7 goes into 10 1 time, which is 3. Oh my goodness, it looks like it's going to go on forever. 7 goes into 34 times, which is 28. Oh my goodness, are we ever going to stop? 7 goes into 22 times, which is 14. How many times will 7 go into 60? Well, it's nice. 9 times 7 is what? What's that? 9 times 7, well, that's more than 60. So 8, what's 8 times 7 was, well, we did that over there, 56. Whoa, goodness gracious. 7 goes into 40, how many times? 7 times 8 was 56, so 7 times 5, 7 times 5 is 35, and then I have my 5 here. Okay, and 7 goes into, I think I've asked myself this before, 7 goes into 50, how many times? How many times did it went in there? 7 times. So that's 49. That was a remainder of 1. I'm going to start this cycle over again. So what this answer equals is 2.714285, and the bar notation has to go over the entirety of what's behind that decimal because that entire sequence repeats. This is still a rational number because was it originally expressed as a fraction, and it can be written with a bar notation. One final example, and then the video will be over. That one went on forever. That was marathon math problem. So here I'm going to put 11 inside, 30 on the outside, add a decimal, and my 2 zeros. So this is one of the times that I would probably use front digit estimation. How many times will 3 go into 11? 3 will go into 11 3 times, so 30 is going to go into this probably 3 times, which is 90. The difference there is 20. How many times will 3 go into 20? That would probably be 6 times, so that's 180. The difference is 20 again. And again, so what we can start to see that we're just going to have a cycle of repeating. So 11/30 is equal to 0.36 with the bar notation just over the 6. Now I know that most of these equaled repeating decimals, most of the time they will probably equal a terminating decimal.